Welcome! Today we'll learn about reflection across a line, also known as R3 in geometry. A reflection across a line is like folding paper along that line. Any point on one side of the line gets mapped to a corresponding point on the other side. Let's start with a simple example. Here's our line of reflection, which we'll call line AB. Now, let's place a point P on one side of the line. To find the reflection of point P, we follow these steps. First, we draw a line from point P perpendicular to line AB. We call the point where these lines intersect point M. Then we measure the distance from P to M. The reflection of point P, which we'll call P prime, is the same distance from M as P is, but on the opposite side of line AB. Let's look at some key properties of reflection. The line connecting P and P prime is always perpendicular to line AB. P and P prime are equidistant from line AB. And line AB is the perpendicular bisector of segment PP prime. Now let's see how we can reflect a shape. Here's a triangle on one side of line AB. To reflect it, we reflect each vertex of the triangle using the same process we use for point P. Then we connect the reflected points to form the reflected triangle. Remember, reflection preserves distance. The distance between any two points is the same as the distance between their reflections. Angle measure. Angles in the original shape are equal to corresponding angles in the reflected shape, and orientation, although the shape appears flipped, all its properties remain the same.